we have a 3 Sabah students to join our class. So start from this semester, this week onward. So no matter how, it's the same. I mean that the syllabus. So maybe my progress of my lecture class will be some behind the schedule and so on. Don't worry, everything will be catch up one. Okay, so I'm going to off my camera so to let you to focus to your lecture class. Because when you come to do a downloading, okay, download the video with my camera on and my video, okay, on the side. So definitely the file size will be larger. So anyhow, so I 69 student. Yeah, morning to everyone. So today I'm focused on the skill. Okay, let me project my screen first. Share my screen. Okay. So okay, I'm going to off my camera. After this, I'm going to do recording. Okay. So okay. Later on, I will going to give you a quiz. The quiz, you need to answer the quiz to take the attendance. To take the attendance. So I come to my chapter number 8. So from this chapter number 8, actually the main thing from chapter number 8 is a calculation. Okay, calculations of VLSM and also the subnetting. So you will see that, you will know that your lecture, your tutor already explained to you the calculation. Okay, the calculation for subnetting, the classful subnetting, and also the classless subnetting, the VLSM, the two workbook you have go through. Okay, so at here, Chaw also we're going to explain one more time about the calculation techniques. Okay, so I will use a past year exam question as an example to guide you to show you the techniques. Okay, how to calculate the subnet, how to create a subnet and create an address. So at this part, you will think that, Michelle, when we are doing a subnetting, or we refer to the YouTube, or we are referring to a tutor explanation, seem like slightly different from your explanation. But no matter how, there is a different way of calculation, slightly different way of calculation. But no matter how, at the end, your answer should be the same. Okay, so what I mean is sometimes you do a max formula. Okay, you have a max question. So the max of question over here, maybe you're using a method A. At the end, you also will get the answer. And you're using the method B, you also will get the answer. Okay, so this is my way to do a calculation. Okay, so if you is or maybe if you have any question, you can turn on your mic, okay, or leave the message in the chat room there. Then later on, I will going to chat on it. I will going to answer your question. So now we're moving on to subnet IP networks. So I think some of you, most of you already start to do your assignment and do a subnetting VLSM for part A and part B. Okay, so now coming to over this side, the objective. Okay, I don't want to talk about the objective. Already mentioned to you, we need to explain how to do a calculation. Okay, for the subnet VLSM and classful subnetting. So give me a minute. I need to go and get sorry, I need to have another jump box. So over here. So yeah, sharing to you first. And share the link with to you over here. Okay. Seem like lessons 84 students. Okay, assume now. Okay. So first of all, I can tell you that this topic, this chapter is very important and it's a common question out from your final exam. Okay, common question out from your final exam, and your practical test will be come up from part A. Part A will be classful subnetting. Class B, part B will be VRSM subnetting. So 20 mark for subnetting. Okay, so that's why don't miss the 20 mark. You can score well in your practical test in your week 13. Okay, practical test will be given in week 13. Okay, so the calculation part is very easy for you to score and to get a full mark. Okay, don't miss this mark. So now, so over here, first of all, I need to go and let you know why we need to do subnet. Okay, why we need to do subnet? Because I think in your uh, packet trace in your practical class, like the tutor only directly told you okay how to the techniques to subnet, but they didn't tell you why you need to do subnet. So now, as you're going to look at these particular things over here, okay, before doing a subnet, according to this particular network topology diagram, so you were able to see that under this part, okay, we have one before doing any subnet. So here we have a one network, okay, here we have one network, and here we have also one network, okay, linked to your internet service provider. So we have a two networks over here, but now we focus on this, okay, because we wanted to do a subnet belong to our organization one, okay, our organization, okay, for our organization. So for our private network, okay, we do our private network. Yeah, our private address. Use the private address to do a subnetting. Okay, our local area network. So if you learn, if you recall back your local area network, okay, and under the Ethernet chapter, okay, Ethernet chapter number 5, you can recall back, you learn about the address resolution protocol. You know that the address, the ARP request, okay, when the PC did not know the MAC address of destination device, so he will going to send out the ARP request message as a broadcast message, okay, as a broadcast message, okay, to everyone, okay, everyone's on your network. So let's say on my this broadcast domain over here, I have a 4D PC here, okay, 4D PC here or 4D host here, included server, laptop lah, your servers, all these things. Okay, we have a 4D 400 hosts over here. You mean that your this particular broadcast message will be going to send it to 400 PC, and all these 400 PC must process ARP, must read the ARP request message, and must going to if that ARP request message is not matched, the target IP address is not matched with his own target IP address, then he need to drop that particular ARP request message. So you imagine if there is only one PC send out the ARP request message to all 4D PC. 400 PC seem like still can able to work on, okay, still can able to accept, like I can say so. But if you think that you have 200 PC, this 200 PC on at the same time, he's going to turn on. And because when he turn on the PC, remember I mentioned to you the ARP table is not the entry, the addresses, the IP address with the MAC address inside the ARP table is not kept permanently. It's just a temporary only. Once your PC is turned on, the addresses, the data keep inside the ARP table will be deleted already. Okay. So therefore, if that is a 200 PC is turned on at the same time, and he are going to send out the ARP egress message, you will be able to see that the entire of the network here, you will have a lot of broadcast message need to be processed by the individual PC or the host over there. So that's why he mentioned about the device using a broadcast in the Ethernet local area network to allocate about the ARP. Okay, so about the ARP, looking for the IP address, okay, to recover the MAC address. Okay, use the IP address, IPv4 address on the local network to discover the MAC address. That is a one part. You have a problem of resolving, okay, solving the addresses. Second thing is, we say that you have this one, let's say you're using a handphone, okay, somebody over here using a handphone, you have a access point, okay, wireless access point, or you're using a laptop and so on. So when they are using a handphone or laptop, using the wireless access, so wireless access, it means that he need to call the DHCP protocol to look for a DHCP server. Okay, so when he going to send out the message, DHCP message, so they are going to send out also is a broadcast message, and he will going to send out this particular DHCP message to request to look for DHCP server. It means that at that moment, okay, the devices wanted to look for to get the dynamic IP address, they send out the broadcast message, and this broadcast message also will going to process and also need to process by the 400 PC in your network. So this is an issue or issue happening when you have a large broadcast message, and sending the broadcast message is not a secure, okay, because you sending to everybody, you know. So that's why to be secure, you need to be to in terms of performance and in terms of security method, you need to be subnet your network, okay, subnet your network. Okay, so over here is that each router interface connect, okay, a broadcast domain, and broadcasts are the only package within its specific broadcast domain. So that's why over here I can see that from this router interface, is that from this router interface onward, this one is one broadcast domain, and this is also is one network. Okay, one network. So after you understand the due to the broadcast message sent in the broadcast domain, and you know that is a define, how to define the broadcast domain. So now you can have a look over here. Just now I already used as an example. This is a local area network number one. Inside got 400 user, okay, 400 PC there. So I already mentioned about that. So what is the problem that? So the host can generate a excessive broadcast and negatively affect to the network. So they can create a lot of broadcast message. So you'll be slow down your network operation due to the significant amount of traffic can be caused. And also the slow down your device, not only your network operation, your switch, all these things need to do a process because it's a broadcast message. And the individual device, the 400 device over there, you will also slow down the device operation because a device must accept and also process each broadcast message. So the solution is you only can go and reduce the size of the network to create a smaller broadcast domain. That's why we need to have a subnetting. Okay, so last week you learned about that we have, okay, this one before go for last week. Yeah, so that's why the reduce the size of network to create a smaller broadcast domain in a process. So this process we call as subnetting. We need to subnetting our network. So when we have a smaller network space, so in this case we call it as subnet. So in here you can have a look at this one. Rather than you have one big broadcast domain inside have of these 400 user here. So you look at the next slide, next diagram here. Over this diagram, there is divided this router divided this 400 user into the two subnet. Two subnet. So here will be 200 user in this particular subnet. Another 200 user will be in this particular subnet. So therefore, when the devices are belong, let's say I got one PCA under this subnet. When I going to send out the ARP request message, ARP request message as a broadcast message, I only going to send out, I will send this broadcast message to this 200 user, and this 200 PCs, they will going to accept the broadcast message and they will going to process the broadcast message. So this one, the 200 here will not be going to send out. So it means that the broadcast message is only be sent, will be sent within your subnet. They will not go. The broadcast message cannot pass from one network to another one network. So again, the broadcast message cannot be passed, cannot send over to another subnet. So this is the reason. So over this side, you were able to see that under 172, if you recall last week class, you know that when the researchers, they design the IPv4 address, they came out this class A. Class A, we look at the first octet number from 0 to 127. This address, this number is referred. If you have one, let's say you have X, this format of IPv4 address. So they are looking at the first octet, this number. So if this number belongs 0 to 127, that address is under class A. So for class B, will be 128 to 191. You must remember this number. You must remember. So then that will be a class B. So class B. So then after that, we have a class C. Over here will be 192 to 223. This is the thing. So now, if you're looking at this address, 172, which is belong to the class B. And for the class B, they already fixed that. Under the class B, there is a 2 octet. This particular 2 octet, this 2 octet will be used for network portion. And then these two, the last two objects will be referred to a host portion. Okay, so the in front, these two number belong to the network portion. This number you cannot modify, you cannot do anything. Just like over here, 172.16. Okay, these are the in front, these two number. Original is belong to the network portion. Okay, I short form network portion. Okay, I put it as NP. Network portion, host portion HP. So from this, once we wanted to do a subnet, we need to look at the host portion. Okay, the bit belong to the host portion and do a subnetting. Okay, we need to look at the host portion to borrow a bit to become a network portion and do a subnet. So in a class B over here, here, based on here, you have 8 bits from here and 8 bits from here. So it means that total up for the class B, you have 16 bit for a network portion, belong to the network portion. And you need to think about how many bits need to be borrowed to create a subnet. So now, before I teach you the techniques to create a subnet, you can have a look over here, this example. So you were able to see that this particular column here, he highlighted over here, and you were able to see that this particular thing is /24. And you know that 172, if this is a class full, we have a two technique under the subnetting, okay? Sorry, discuss. So under a subnetting over here, under the subnetting, we have a two technique. One is a classful. We say is classful subnet. So just now my explanation over there is classful subnet. Okay, classful subnetting. Okay, classful subnetting. Classful. Reason is just now I told you you need to identify your address whether it belong to which class. So from 0 to 127, 128 to 191, 192 okay, to 223. Looking at your first octet, that is what I mentioned, your first octet, to determine your classful subnetting. Okay, but for the another one called classless subnetting, which the technique is called it as a VLSM, variable length subnet mask. Variable length subnet mask. So from this VLSM variable subnet mask under the classless over here, what you need to look at here. When he given you a VLSM subnetting, he give you the address, let's say 192.168.4.0/26, for example. He give you this address. Okay, you no need to go and look for what is the class. You no need to determine what is the class for ABC. Sorry, this is a C, luckily. Okay, so you no need to determine what is the class ABC or not. No, most important thing is you looking at the prefix length over here. Look at this prefix line. Okay, you will say, hey, Miss Chaw, if this is a 192, should be belong to the class C, or over here should be belong to /24. Why here is /26? It's no wrong. Okay, no wrong at all. Okay, because it could be possible this address already been used for subnetting, already have a number, they already use 2 bits from the host portion over here, already created a subnet. And now this is an address that you can continue do subnetting. Okay, possible. Okay, so you don't mean that, because here is called classless subnetting. So now, next thing is over here, you think about borrow. You need to borrow. Always think about classful subnetting. You need to think about borrow the bit. What bit? From your host portion bit. Okay? Host portion bit to create subnet. This is the thing. You need to borrow. So that's why I mentioned your class B, okay? The class B over here, if this is a class B, you have a 2 byte. It belongs to the network portion, and you only have 1 byte. Thank you for editing. Okay, sometimes I have typo error, and you have a 2 byte for 2 bytes for this host portion. Okay, you need to think about borrow. But another one side for the classless subnetting, you need to change your mindset. I need to think. You need to think. Okay, how many host bits that I need to keep. The what is keep? How many host bits that you need to keep to ensure you have number of host addresses. Okay? So this one is talk about keep. You need to keep what? You need to keep your host bit. How many host bit that you need to keep. Okay? Then when you keep that particular host bit, you will have that numbers of host address. You are not thinking about number of subnet you create. But over here, you need to think about how many bits you borrow to create a subnet. This is create a subnet. This one is you keep the bit to ensure that you have these numbers of host address. So this is a part over there. Next thing is, okay, in the question, usually for classful subnetting, definitely they were going to tell you number of subnet he wanted to be create. Number of subnet he wanted to be create. Okay, want you to calculate. He will give you this, or he will show you the diagram in the exam. Possible, they will show you the diagram. They tell you, okay, I got this network topology. Okay, so determine how many networks over there. First question they were going to ask, determine how many network in this topology diagram. So if you are determined, if you're going to check your diagram and you determine the number of networks wrongly, number of networks in the diagram wrongly, then you were going to borrow a wrong bit to create a subnet. Okay, so it's very important from that. Okay, so from this one, usually, okay, for this one, what he's going to do it, usually he will going to tell you each, okay, each of the subnet, okay, what is the, okay, in each of the subnet, what is the maximum number of usable host addresses that he want. He will going to tell you. Okay, so based on that, you need. And from here, always from this one, always do a subnet from the largest numbers of hosts. From the largest. So then do the smaller, from large to the smaller. This is a fixed technique. Okay, No matter how you do calculation, must be from largest. So next thing, this one they won't call largest because each of the subnet having the same number of address. Okay, each of the subnet having each of the subnet, okay, has a same number of host address. Sorry about that. Okay, so this is the differences between classful subnet and classless subnetting. Classful subnetting and classless subnetting. So I move back over here. So hold on. So I move back to this slide. Okay. So don't worry, I will come back later on, go back to that screen again. So I wanted to tell you over here, the diagram over here are giving you the concept of classful subnetting. Here explaining in terms of classful subnetting. Okay, so classful subnetting. So that's why over here, you were able to see that he borrowed the entire byte over here to do a subnet. Okay, original is /20 /16 because this is belong to class B. Okay, this is a belong to the class B. Class B. Okay, that's why it's /16. 255.255.0.0. That is a subnet mask. So in here, he's going to borrow. Make it simple. He's going to borrow the entire the third byte or the third octet the third octet. Okay, to become form by right. This one is belong to the host portion. Okay, belong to the host portion. He borrowed the third octet to become a network portion. You were going to ask, Miss Chow, why must we borrow from here? Why we cannot borrow the last byte over here, the fourth octet over here? Okay, why must be here? Reason is this one is a first two. These two are the network portion. So when we borrow, definitely we're going to borrow the bit from the host portion, which is nearest. Start from the nearest to your network portion one. Okay. So over here, he borrow a 8-bit. Okay. The entire of this number third octet over here, because from /16 to become /24, it means that he already, the differences is 8 bits. He borrowed the entire this byte to become to change it to become a network portion. So that's why if you have a 2 power by 8, it means that you have 2, 5, 6 network. Okay, so you were going to ask, Miss Chow, why must be going to power by 8? Okay, and over here, there is only start from 0, and here is 1. And why you say that that is a 2, 5, 6 over here? Okay, hold on. Okay. Sorry, I accidentally stop my screen. Click on the wrong thing. So now we come to this side. Okay, now just now I said that 172.16.0.0, this is the original /16 original and class B. And now the question is, based on that, he borrowed this entire byte. Okay, in terms of diagram, by right, he should give you the number of subnet he needed. Okay, then determine how many bits need to be borrowed. Okay, so we skip that part first to explain the concept of borrowing a bit to create a subnet. So just now I already mentioned this is belong to the host portion, and this one original is belong to the network portion. So when you borrow this particular byte to becomes a network portion, it means that from here we expand it. We look at your bits 1, 2, 3, 4, 5, 6, 7, 8. So you say that 2 powered by 8. We have a 256 subnet. We can create 256 subnet. Why? Why that is a 256? Okay. Reason is your bit. Why is 2? Why is must be always the base is 2? Reason is the bit pattern. You look at your bit pattern and your this bit, each of this bit, the value of this bit is only either is 0 or 1. That's why you have base 2. And why is 8? Because you are borrowing the entire byte to form the host portion to change it to become network portion. So that's why over here the prefix length to become /24. So in terms of bit pattern, just this is a bit pattern for this part only. For this part only, I expand it. So when there is a different combinations of bit pattern will generate a one value, and that value will be a unique value, and you cannot have a same bit pattern. So from here, the first bit pattern definitely will be all 0. So that's why change to the decimal value, there will be the 1. Dot 1, no? Sorry, dot 1 pula, dot 0. So then the second bit pattern, will be 0, 0, 0, 0, 0, 0, 0, 1. So that's why our decimal value will be 1. So this is a, under the decimal, the value, the position value here is 1, 2, 3, 3 pula, 4, 8, 16, 32, 64, and 128. Okay, why is 1? Because this position, at this position, we call it as 2 powered by 0, the position number 0. This is a 2 powered by 1. That's why your value is this. Okay, so I hope these things should be able to understand already. I hope that you understand from that. And this is a 2 powered by 2, 2 powered by 3, 2 powered by 4, 2 powered by 5, and 2 powered by 6, and 2 powered by 7. Okay, remember this is a number. This is a number of bit I go and borrow. And this one is a position value. Okay, to convert your binary to the decimal. So therefore, when I come to the number third bit pattern, okay, so I will have a 0, 0, 0, 0, 0, 1, 0. So that's why change to the decimal value will be dot 2. And so on. So they have a different bit pattern. So from here, the last bit pattern under number 2, 5, 6, number last bit pattern now should be 1, 1, 1. Here missing 1, 0. 1, 1, 1, 1, 1. So that's why when we convert these all ones into the decimal value is dot 255. So therefore, when from this 0, this particular 0 counted 0, dot 0 is one subnet. Okay, and until your dot 255, this is another one subnet. So the total subnet from dot 0 to dot 255, you have 256 subnet. Okay, so this is the reason why we are using 2 powered by 8. We say that we have a 256 subnet. So remember, don't go to -2. Oh, Miss Chow say each subnet there is a broadcast address cannot be used and there is a network address cannot be used. That is referred to address inside your subnet. Now I'm talking about total subnet, not the address. So you cannot -2. Some students will make a mistake on this part. Okay? So you cannot -2. You -2 is inside the address range there to count how many usable address. So therefore, come back over this side, over here. So therefore, you will able to see this diagram. He will have this number .0 and here is .1 and here is first subnet. Sometimes you say, and Mitchell, you use the first subnet. Then in terms of a reference book, they were going to use subnet 0 is equivalent to first subnet. It's fine because he's using the subnet number. He ring the subnet number start from subnet 0. Okay, then he give you the subnet number there. Can. Okay, so I'm use the term called first subnet. It's fine. Okay, some usually Cisco workbook or the reference book or your question that you saw, they were going to mention about subnet 0 is a first subnet. Okay, just a number only at the start from 0 number. Okay, so now so from here you were able to see that this particular diagram already broadcasted into the two different subnet and the network address. This is a one network already. Okay, so over here the network address, this is a network address. Okay, and this is a network address. So this is a network address. So now we need to think about how many hosts can be connected in this network. Once you have borrowed the entire octet, the third octet from here to become a network. So you need to think about how many hosts can be added in, the maximum hosts can be added inside these networks. Mean that how many host address, usable host address that you can have for each of the subnet for the classroom. So therefore, in this case, you come back to here. Okay, now, due to you already borrow this particular byte to become a network portion already. It means that you only remaining. So in here, you no more this already. So you only remaining this particular byte to become a host portion. So therefore, you need to use the formula again. Okay? You need to use the formula again to calculate how many, okay, how many hosts, okay, over here, host address. Talk about the host address available. Okay, available in each subnet. In each subnet because they are equivalent because each of only this number are changing only. Am I right? Each of the network, this number are changing. But the behind this one, you still remain to have a one byte, the last byte to become a host portion. So therefore, you are using 2 power by 8 equivalent to 2 by 6. So now you're looking at the last byte. Okay, so you have 256 total up. You have 256 address. Because now we're looking at this address also can change the bit pattern, just like your host portion, just like your subnet bit over here. Also can change the bit pattern. Okay, like that. So total up, you have 256 addresses. Okay, 256 host address. But when we're going to say that we wanted to know, okay, the address can be used in your network. Okay, how many? I add the word usable. When I add in the usable, how many usable host addresses available in each of the subnet? So in this case, I need to minus 2. I minus 2 due to the reasons of the network address, and also the broadcast address. These two addresses are reserved for each of the network. They are reserved for each of the network. You cannot assign these two addresses. The first address and the last address, okay, are reserved. You cannot assign to the PC. You cannot assign to the switch for VLANs, and also cannot assign to the these routers interface. You can't. So that's why you only have 254 usable host address. So that's why when you look at the question, you need to think carefully whether they are asking about usable or not. If you are talking about usable host addresses, you are required to minus 2. Okay. So in this case, if the question did not mention usable, he only mentioned what is the total, or what is the total number of host addresses. He don't have the word usable, you no need to minus 2. Okay, usually question we're going to ask like that, so be careful about the word usable, minus 2. So in this case, it means that total up you have 256 address, but only 254 addresses can be used inside your network. And these 254 addresses must is equivalent to, I go back to your slide, yeah. I'll go back to your slide. It means that over here, it means that in this case, I will have this part. 2. Here I have 256, total up 256 address. And here I also have 256 address, included this network address and included the broadcast address. Okay, the broadcast address. Same thing over here. But I wanted to minus 2 will be equivalent to 254. It means that over here I only can have the usable addresses PC that I can have. The maximum is 254. This is a part over there. Okay, minus 2. So now come to the reason for subnetting. Just now already mentioned, reduce the overall network traffic, improve the network performance. Okay, why we need to do subnetting? Enable the network administrator to implement a security policy. Okay, at this moment you are not going to learn how to block the access, okay, how to filter and so on. Okay, if you are in other like if your program structure have advanced computer or computer network, you were going to learn about the security policy. Certain configuration can block the traffic. Okay, so it's that which subnet are allowed or not allowed to communicate to each other. So that will be about that. So therefore, we cannot just go and join all the devices into the one network, because you need to determine the reason why you need to do subnet. So now, as a network administrator, you can group the device or service into the subnet according to the location. For example, over here, subnet by location. Okay, over here, okay, by location, like this particular building. So there is mentioned that there is a first floor, second floor, third floor, fourth and fifth floor over here. And now he using this number. This is a class A. Class A. Original should be class A should be 8 bits for the prefix length. But now he gives you /24. So you know that this already have done a subnetting, and he have borrowed how many bit? He have borrowed 16 bit. He have borrowed 16 bit. This bit, this bit, this bit, all this 16 bit. Even though here is 2 or tag, refer to a 16 bit. He have borrowed a 16 bit to do a subnet. So in this case, you only have, okay, it's only have, based on /24, you know that you have remaining. You're using 32 minus 24. It means that you have remaining another 8 bits for your host portion only. So therefore, in each of the floor over here, maximum, you only can have a 254 usable hosts only. You can plug in or add the devices. Maximum is 254 each of the floor according to here. So this is a subnet according to the location. Okay, so in your assignment part A over there, actually we do not tell you whether you do subnet according to the location or according to the between the organization unit. Okay, whether you want to group according to department, I don't care about your location. Okay, I only in your assignment part B, I only mention location A, location B, and then first floor, certain location have a first floor and second floor. So if you wanted to divide it in terms of department, so it means that you're using this particular organization unit. Okay, it means that I don't care about the location. Sometimes maybe building one, okay, okay, and the building two, there is a two same department staff in building one and building two. Can happening also. Just like in TAR, you see, if you know that we have a student affair department. So under the student affair department, you have this particular in the block A there, you have a one counter there. Then at the back over there, there is another student affair department regarding to the sport. And then you have a counseling the department there that is referred to counseling things. Okay, the servicing over there for providing a counseling service. So all that belong to the student affair department. So therefore, you can do subnetting according to the organization unit. Just for example, administration, student, accounting, and human resource. So I don't care whether the human resource department, the staff is sitting in first floor, and maybe second floor also got human, also have a staff belong to human resource department one. So you want all the staff, okay, who are belong to the human resource department group it together. Okay, so this is a one part over there. So therefore, you were able to see that. They are grouping in terms of a organization unit. Another one of grouping is according to the device type. I don't think so. Your assignment question will according to the device type. So the device type is, what he was going to do here is they were going to group. Okay, so all the server, he will going to host it in one network. So all the server are going to located in one subnet. Okay, so he used the .3. So the in front this number. Okay, why he .3? Hey, Mitchell, he borrowing 2 bits. He borrowing 2 bytes to create a subnet. So usually we are using the in front subnet address first. Okay, so later on we will expand it. Okay, to use it because your bit number is 10 dot this number. Okay, x this one is host. So in this case we changing the number bit pattern from 0 0 0 0 0 0, then 0 0 0 0, then after that here is 1 0 0 0 0, then here also 0 0 0 0 0. So that's why they are do like that. Okay, so and the bit pattern. You say, Chaw, where is a 10.0.0.0.0? So in this diagram, they may going to use this as reserve. Okay, this network, the first subnet he's going to reserve. Not necessarily must be saying that, oh, I must be assigned this port, must be a first usable address. Okay, not necessary. Some of the organization, they will assign this as a last usable address, or they are assigned, or you are reserved. Just now you have two powers, you're using /24, and you have a 2 power 8, you have a 256 minus 2, you have a 254 host usable host addresses there. So in terms of 254 usable host addresses here, sometimes the organization will have this idea saying that, okay, the first 20 usable host addresses are reserved and used to configure the intermediate devices, the routers interface, the switch, and so on. Then start from the after the first 20, then stuff after that, number 21 onward. The 21 onward usable address will be used for the host portion. They have this kind of concept. What depends on their network policy, how he wanted to be designed. Okay, so therefore you will able to see this particular thing is you need to understand the prefix LAN and subnet mask, and then from the prefix LAN or subnet mask, okay, either one sure he will going to give you, then you're going to determine. Okay, they are not given you, it means that they are going to give you the addresses. Just now I mentioned 10, you know that this number is a class A. So from class A, you know it's a prefix LAN /8. So from there, you know that class A/8, it means that this is already known as a network portion. Then this one will be the number of host address. So just now, previously, I didn't mention to you why you get this number of maximum host addresses is because you're using 2 power by 24, then minus 2. Okay, so it means that each of the network you have this number of address. Okay, so all this already minus 2, and this one is /16 is you have the behind 2 byte for the host portion, so 2 power by 16 minus 2, so you will get this number of usable host address, and this one is 2 power by 8 minus 2, you have this number of usable host address. So that's why over this particular slide here is talking about the classful subnetting, because he's going to ask you subnet are created by borrowing. You need to borrow the host bit for a network bit to become a network bit. That's why it's borrow. So this explanation is talking about classful. Okay, you will say that, Chaw, why the slide must be, why you know this is referred to the classful? Okay, as I mentioned, in the history, when they are designs the IP addresses, because if you just die follow class A, B, C, okay, D and E, definitely there is a maximum of networks and maximum of host addresses, usable host addresses that you can have in in each of the network. So due to this reason, they come out the idea classful. He come out the idea classful address. After doing a classful address and still facing the problem as not enough addresses, still cannot able to fulfill the current network requirement, and so many devices need to have access to the network. So therefore, the second solution given by the engineer or network engineer, they come up the classless subnetting. Okay, using a VRSM. Okay, use this method. Don't think about classful classes. So this is the next method. But however, the classless VRSM subnetting is just a temporary solution. They are not able to fulfill the current devices, the span of the network, the number of networks and numbers of host addresses in the whole world. So therefore, at the end, they come out IPv6. This is the reason why they come up the IPv6 protocol. They come up a new protocol, IPv6 protocol, and then they come out the IP. With the IPv6 protocol, then you have an IPv6 addresses. So by having this thing, then they're given largest. Okay, now I don't want to use classful. I'm using 32 bits. Okay, don't be so stupid already. Engineer that don't think about 32 bit. We give largest, so we are using 128 bits. Total out 128 bits. Oh, we don't use decimal value already. We use hexa value because it can be used to represent more bits. More addresses can be created if you are using hexa decimal, because the changing of the number. Okay, because hexa is base 16. Okay, base 16, and your this number decimal is base 10 only, base 10. Okay, so that's why base 10 is only can be 10 number. Now I got base 16, I got 16 number, extra 6 numbers there. So that is the reason why. Okay, the step. So even though he did not show me that, or this is belong to classful, I know that according to here, borrow the whole speed for a network portion to become a network bit, which is a classful subnetting. So more whole speed you're going to borrow, it means that you will create a more subnet. Okay, you can define more subnet. You can create more subnet. So in this example, just wanted to show you this is a class. Okay, original, this is a class A, should be /8. But now he give you /16. Okay, mean that he borrowing 1 byte from here. So this byte can be from 0 until 255. Just now already mentioned to you. So, and then what is the address range? You were able to see. So you have this number of, it means that this number of addresses, you can go and modify it. Okay, the bit pattern here. You have a 2 byte at the behind. You can do modification. So that's why we changing the number stuff from the last octet over here. Do you see that? We are not changing here. We cannot say, oh, we are not using 10.10. Michelle, you said this is a network portion. Okay, sorry. Maybe I'm used here. Or Michelle, you said that 10.10. Okay, oh, sorry, 10.0. Okay, this is a network portion. Then we start to change our host. We start from here, 1.0. Cannot. Okay, because network portion from the left hand side, host portion from the right hand side here. Right hand side, this is the left hand side. So when you change the bit pattern, you change from this byte onward, not this byte. Okay, so that's why the bit pattern will be a from these two will be 0 0 0 0 0 0 0 0 dot 0 0 0 0 0 0 0 1. So this is a bit pattern from here, from this. So what is the last? This is the last usable address. Okay, so last here is this pattern. Okay, when you have this one is 11111111 dot 11111110. Okay, the bit pattern. Okay, so we start to do a changing. So only we change this one from 0 to become 1. That is a broadcast address. Okay, so remember, this is a broadcast address. So it means that from here, from this 2 byte, 2 power by 16. Okay, 2 power by 16. So it means that should be a 65536. Okay, 65536 minus 2, you have 65534. 4 usable address. This one is usable address. Okay, from 0.1 until 255.254 total up, you have 65534 addresses. Okay, so this one will be the network address, this one will be the broadcast address. So it's same. Okay, so over here you can create 256 subnet. Okay, you can create 256 subnet, and each of the subnet, this will be the usable host addresses. So I give you a break. Let me finish this one first. Okay, so this one will be talking about sorry, yeah, correct. Okay, so this one will be telling you that this is a class A also /18 /8, not 18, but now here becomes /24. It means that he borrowing this 2 byte to become subnet. Okay, he borrowing this 2 byte to create a subnet. So therefore, the possible subnet that you can create is 2 power by 16. You have 65536 subnet. You cannot minus 2 because this is talking about subnet. Okay, you cannot minus 2. Okay, so it means that you only balance of 1 byte to become a network portion. So therefore, from this dot 0 is 1 value. Okay, this dot 0. Okay, I'm looking at the last octet. The dot 0 is a network address. So then dot 1. Okay, dot 1 over here. Okay, dot 2, dot 3 until your dot 254. This one is the last usable address. This is the first usable address, and this is the last usable address. And over here, dot 255, no more already, because all the bit pattern will be 111, all set to 1 already. Okay, because it's all 111, 111, 1 already. No more changes already. This is the last bit pattern. So that's why over here you have 256 addresses. Okay? Minus 25, minus 2, you have a 254 usable address. So each of the network, you having the same number of usable address. You can see that. Okay, the changes is only at your network portion. You can have a look. This one 0.0, 0.1 is another network. Can see or not here? 0.0, 0.1, 0.2, then 0.255. You can see this bit pattern already reached to 255. Then what to do? You change your in front, which will be affected to your the in front octet, which will be the second octet here. So your second octet will be changed from 0 to become 1. Then your third octet here will start from 0 again. So then here will be dot 1, dot 2 until you reach. Okay, you can see that you can until dot 100 at the end. Your bit pattern will be become 255.255. That is reason why you can have 65,536 possible subnet, because your bit pattern are changing. After you change this, then you affect to the in front of that. Okay, so this number are remain. Okay, so that's why this is a prefix line talking about the subnet. Okay, this is a /24. So how? If you're going to borrow 1 bit, you only can create 2 subnet, and then you have remaining another 7 bit. So this is a 7 bit. So that's why 2 power by 7 is 128. Okay, 128 address. So minus 2 will be a 256 number of hosts that you can have. Okay, number of hosts that you can have inside your network, maximum hosts. So this one, you will able to see that. So that's why you need to think about when you are borrowing, once you're borrowing a bit to become a subnet, so this particular bit is no longer to become a network portion because it's belong to the network portion. Therefore, from /24, you need to change it to become /25. And your subnet mask, you cannot be .0 anymore because you need to use this particular bit already been used for a network portion. So for the subnet mask, you must be set it as 258. Under this possession is 2 power by 7. That's why the possession value here is 128. So you need to have .258. Okay, same thing from the rest. This one will be a 258 plus 64. Okay, 258 plus 64 because you are borrowing 2 bits to become a network portion. So that's why you have 2 power by 2, you will get 4 subnet. And then the remaining of 6 bit, 2 power by 6 bit, actually you got 64 addresses. But however, he wanted to know the number of hosts, maximum number of hosts that can be have it inside each of this network. It means that you need to minus 2, so you will get 62. Okay, so I will going to from this video demo come back. I will going to, after the break, I will going to explain to you, and I will going to use the past year exam question, okay, as your example, how to do calculations on it. Past year exam question. Now we do fill on it. After that, after this, we are going to do a classless subnetting. I also using the example. Okay, one you have the concept over there. Okay, so now is 9 according to my clock lah. Okay, 13. So we come back at 9:20. So I will going to share capture screen and share some past exam question to you. Okay, so at the same time, I also go and copy this particular link to you. And this is only 3 questions for today. For today, quiz. Okay, quiz for attendance. Okay. So just a 3 question is very simple one. Okay, so you can go and do it. So I'm stop sharing. So while yeah, you can go come back at 9:20 am, or you have any question you may going to ask. I'm stop for recording. Then I will going to record for the second session.
Miss,
Yes.
can go to the first slide.
First slide.
Yeah.
Chapter 8, first slide.
Yeah.
Over here. Sorry, I need to project it first. Yes. Okay. Is it here?
Oh no, the next slide.
Next
the
slide.
6.
Okay.
So the left one is the classful subnetting, and the right one is the classless subnetting. Is that correct?
Yes. From here, I can say that they are using classful subnetting. Okay. Here, no classful, and this is a original telling you that this is a one broadcast domain. Okay, before doing one subnet, there is a 400 user need to do accept the broadcast message, process a broadcast message. The domain is really large. So that's why he going to telling you that if we divided our number of user or number of hosts, okay, over here the user is referred to the host, even though he mentioned a user. So number of PC into the 2 portion, 200 PC. So in this case, we can reduce our broadcast domains. Our broadcast domain is smaller.
Oh, okay.
Can ah?
Okay.
So
Okay, thank
actually,
you.
this one actually is a classful subnetting. This one is a classful subnetting. It's not a classless.
Oh,
He
okay.
just the intention is wanted to tell you broadcast domain is become smaller after you do subnetting. Okay, you will speed
Okay.
up your process. Okay. Anyone still have a question? Okay. While waiting the time pass, let me go and capture this. Okay. We use a jump box. Cannot enlarge one. Okay. I seldom use it. Okay. Regarding to the Wong Lee Jun's asked me a question regarding to the Part B assignment for user profile. The email is write two member emails. Okay, yeah, can do so. Okay, because you only submit. Now, there is a difference. Okay, now you can see that under your compared to your Part A and also your Part B. So under your Part A, I did mention you must change your username, the user profile name to become your name. Okay, so which we will going to ensure that the work done by you. Okay, your part A, the 2 question in the part A is done by you. So, and there is a, we can able to see, okay, and there is an automatic marking features available there. So, this the reason is we don't want you to download the answer from a website and then become your answer. Once you change your user profile name, everything will be set back to 0. That is a reason from part A, you need and you must going to give user profile. Okay. So for your part B, as you know, part B is create. You're using a packet tracer, you create your own network, you drag the devices, and so on and so forth, you design. So yeah, it's good to put in your user profile to identify this is your own work. Okay. So even though you modify your user profile, they will not be auto reset because you do not have an auto marking features over there. Okay, so you can give your user profile, okay, your name or your team member name and your email address as the one copy. So to identify that this is your answer. Okay, am I answering your question? So because the 2 members are submitting 1 copy of packet tracer for the part B answer. Okay. Yes, thank you. So now I'm going to jump board over here. This one, the board over here, and we do a calculation. Okay. So because here have a video to demo, I think that you can go and watch the video when you are free. Okay. So if you think that my explanation is still not clear, then you can demo, you can view this video, okay, and learn how to do subnet mask, okay, how to do they still got a video how to find out the magic number. Okay, I forgot to mention about the magic number over here. Okay, so then later on I will going to tell you the magic number and here how to create a video. So rather than watching the video, okay, so let me explain to you. If you still not clear, you can refer to the demonstration over here. So now I'm more concerned on whether the skill that you need to learn to answer the exam question and also your practical test question. So I already mentioned definitely exam will be up from this topic. Okay, so therefore from we are looking at the slide number 3 first. So from this question, actually I'm taken up from a past year exam question which will belong to the bachelor. Okay, Campbell University one. Okay, for the Campbell paper, not Thai UC paper. No matter how, this is a February 2020. Mean that just last year paper, and this will be the question that we have. Okay, this one is before MCO question. Before MCO question, and let you know how we're going to answer it. So I hope everybody also come in, and Miss Chow will make a mistake also. Okay, so therefore, at the same time, you also help me to detect whether Miss Chow have any mistake or not. Okay. So I just quickly to go, meaning is I want you to understand the classful subnetting first. Okay, that's why this question is a classful subnetting. Okay, so over here, identify before classful subnetting to answer the part C here. Let us quickly go for part A. How easily to score others question the marks over here. So if this is not a FOA online assessment, no, this is a face-to-face exam, face-to-face exam, and face-to-face exam they are not really talk about critical thinking from this question. Is more on calculation part. Okay, so identify the address class. So this is talking about address class and also the default subnet mask. It means that from here, you need to going to look at your class A is 0 to 127, 128 to 191, 2 to 1, 2, 2, 3. Okay, A, B, C. So therefore, from this question over here, 2, 2, 3 along to this part, this is a class C. Okay, so you mentioned class C. Okay, class C, and the default subnet now will be 255.255.255.0 because it's original default before doing any subnetting. Okay, so this one is dot 9, 9 dot. So look at the first octet. This is a class A, short form. So that's why the answer subnet mask is 255.0.0.0. And this one is 190. Look at this one. 190 is belong to class B. So that's why I will have a B. And then the default subnet mask will be 255.0.0. So easily score if this is a face-to-face exam. But I don't think so. FOA will come up this so easy question because this one is immediately you can refer to the book and you can get it the answer. It's not involve a critical thinking. Okay, now move to the next thing. However, you need to know all this. Okay, now we're going to look for the second question. Determines the number of usable host IP addresses of the following subnet mask. So he given you this particular subnet mask value. Okay. So then he give you dot 128. Okay. It means that if you're recording to this number of bits here, it means that this decimal value, it means that the bit pattern from this dot 128 is 1. Is it something?
Miss,
Yes.
the record.
Oh, thank you. Thank you for reminding me to do recording. Thank you. Yeah, because one I changed to my screen, I forgot. I can't see the Google Meet, and I forgot to record. So when we come to look at this particular bit pattern here, okay, the decimal value gives you 128. So if come to the bit pattern, will be 1, 0, 0, 0, 0, 0, 0, 0. So in this case, it means that because this is a subnet mask, it means that you set to the 1 is referred to the network portion. So you mean that at the behind here, you total up, you have a 7 bit. These are the 7 bits belong to the host portion. So you wanted to know how many host IP addresses that you can have. That's why you need to look at the host portion bit. So total up, you have a 7 bit. You only have 7 bit. That's why you are using 2 power by 7 is equivalent to 128. But the answer is not 128, because here asking, I want a usable host IP address. And you are confused. Miss Chow, over here is usable host IP address. But over here, your slide here, I go, you don't confuse. And the term I'm using here, just now, this one, number of hosts. What is the things different? This one, yes, is a number of PC, number of devices can be have it in your network. Actually are the same. Okay? Are the same. Number of PC that you can have it in your subnet is equivalent to number of usable host addresses that you can have to assign to the PC. Okay? So that's why the terms are, even though terms are different, but they are used to refer to the same thing. So therefore, we need to minus 2. You will get 126. Okay, so this is a 126. So now come to here. So you were going to get that, this one. They didn't tell you whether this is a class A, class B, or classful address, classful subnet master, or cluster subnet mask. We don't care about that. We're going to look at how many bits for our network portion. So from here, because they are starting from 240, so that's why we are going to look at if I convert this number, this one, okay? So this number, because this number, the bit pattern will be, okay? So 2192 plus 128 plus 64 plus 32 plus 16. Okay, so mean that this particular thing is 1, 1, 1, 1, 0, 0, 0, 0, dot 0, 0, 0, 0, 0, 0, 0, 0. So this one, this value is referred to 140 because I'm using 128 plus 64 plus 32 plus 16. So that's why the first 3 bits are set to 1. Okay, so it means that I only have remaining how many bits for host portion? I have this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have a 12 host bit. So 2 power by 12. Sorry, Miss Chow don't in front of me. I don't have a physical calculator. So therefore, I need to use a computer's calculator. So that's why I'm using 2 power by 12. I will get 4096. Remember, minus 2. So I have a 4096. Okay, this is a total address. Total address available in each network. Remember, each subnet. So I need to minus 2. The usable host address is 4094 usable host address. Each of the subnet, I have this 4094 usable address. So that is the reason why you have this part over there. Okay, so now we're moving on. Okay, we're moving on to the classful subnetting. Why I know that it's a classful subnetting, as previously I mentioned to you that you need, when there is a classful subnetting, sure, they were going to tell you number of subnet, or they're giving you a diagram, ask you to determine how many subnet are there over there inside the network. So therefore, over here, so you have been given a network address. He given this network address to create subnet. Can you see that? He create subnet. So total number of needed subnet is 60. So the total number of needed usable host address for each subnet is 1,000. So definitely you need to look at the number. Even though it's a Mitchell here, he telling you total number of usable hosts in each subnet. You are equivalent, each of the subnet you have equivalent to have 1,000. You make mean that you at least you give 1,000 usable hosts to make usable hosts. So therefore, in this case, 128.77.0.0, this address is belong to class B based on here. Class B 128. So slash 16 original. So in this case, okay, this is the original. So mean that in front over here already belong to the network portion. So you only have the behind these 2 bytes is belong to the host portion. So in terms of here, they already told you that he need 60 subnet. So I expand my bit pattern. Don't worry if you take longer time to understand. Okay, take longer. You say, Mitchell, why so spending time to draw all this zero out? So I just wanted to let you have a clear picture. Once you understand a clear picture, you can shortcut already. You can do shortcut. So now I wanted to introduce to you what is called magic number. Okay, magic number. So now, when you're going to borrow the bit, as I mentioned, you need to borrow the bit start from here near to your network portion one. So you borrow 1, 2, 3, 4. Is it 4 enough? Cannot, because 2 powered by 4 is 16 only. Am I right? Okay. So that's I need to have 5, 7, okay, 4, 5, 6. So if you're using 2, 2 power by 6, I got 64 subnet. It's already enough. Already enough. 64 subnet. Okay, because here you have, if you want 60 only. So it means that over here, I'm go and draw a big line. Okay, line over here. Okay. So now, you will be careful from here. So this is a bit that you borrow. 6 bit. You're going to borrow. Borrow. So now, this is a remaining of a host portion bit. All here is belong to the host portion bit. You only got 8 plus 2, 10. So that's why 2 powered by 10. Okay, sorry. 2 powered by 10 should be 2 powered by 10. You should have a 1024. So that's why over here 2 powered by 10 is 1024 minus 2. You have 1022 address. Still enough, right? Because you want 1000. Each of the subnet, I give you 1022 address. Is enough already. So that's why the first question, before I'm continue, let us, before I introduce a magic number, I just from here, what is the address class for the class 128.77.0.0? The answer is B, 1 mark. So class B, he talking about address class. Okay, what is the default subnet mask for this particular address? So the answer is 255.255.0.0. Another 1 mark. How many bits are required to borrow in order to create 60 subnet? The answer will be 6 bit. 6 bit. You need to borrow. So how many subnets are created? So that's why you use 2 powered by 6. You will have a 64 subnet. You will able to create it. So no need to minus. So then over here. What is the total number of host addresses per subnet? So each of the subnet, how many host addresses? It means that this one is included your network address and also your broadcast address. So therefore, I will give the answer is 1024 because I'm using 2 powered by 10. 1024. So another 1 mark. So how many usable hosts, because of usable host addresses per subnet? So I will have 1022. This is the answer. So easily can score the mark. Am I having a... that's all from this part. Let me go down. Sorry, I forgot to capture this one. Still got part C over here. That's why I said that why there is something missing. Okay, the question is hanging. So you will able to see this kind of question. You'll be able to have something like 8 marks over there. No, not only 8 marks. This one almost 20, 15 or to 16 questions. So I want to add. How to act? Okay. Sorry, I jump. Okay, because this question cannot give me anyone. Cannot. This is a note. I seldom use this one. Sorry lah. I must be come to here lah. Okay. A minute. So give me a last little bit. So I continue. We continue from the previous question. So what is a custom subnet mask? So if you going back to your custom subnet mask over here, okay. Oh, somebody help me to add in. Thank you. I saw somebody add in for me. Okay, so that's why what is a custom subnet mask? If you refer to here, you already borrow this 6-bit. So that's why you are required to make it to become set 1. 1, 2, 3, 4, 5, 6. So that's why you understand. Over here, the shortcut mean that over here you know that if all numbers set to 255, all bits set to the ones, the decimal value is 255. But now you only got these 2 bits not setting to 0. So actually you can minus now. You can minus 255 minus 3 become 2525 2. Okay, so 252. Or you say, Mitchell, I still not very confident what you're going to say. So you can use 128 plus 64, 64 plus 32 plus 16 plus 8 plus 4. At the end, you also get back 252. You also get back the same value. I minus 3 is because this one. This is a 1. The possession value here is 1. This is a possession value of 2. I minus 2. So I straightforward, I can get 252. Okay, so remember, this is only refer to the number third octet. Number third octet, you are borrowing a bit from the host portion to become a network portion. So therefore, my subnet mask at the in front, I'm still remaining for the first 2 octets, still remaining as 255. No change. Only the third octet is 252. And then for the last octet, you know that the last octet over here is entirely used by the host portion. That's why I know that the subnet mask will be set it to all 0. So I no need to do any calculation. I just going to write 0 because under the host portion bit will be set to 0 when they are host bit. Okay, host bit. Okay, so now therefore over here they are asking you to create a subnet. Okay, compute the list of first 4. Even though you can create 64, you can create 64 subnet. Okay, you can create a 64 subnet, but usually question will go and ask you to create a subnet for the first 4, first 5, or first 3. That's why you will able to see that are using in this question they're using subnet 1. It's refer already tell you first 4, but the sequence number he put subnet 1, 2, 3, 4 is first 4. Okay, so he did not start from 0. It's fine, just a numbering only. So now from this question, how we're going to create the address from here? So I come back. So you have a subnet address slash prefix length. Remember, you must be indicate your prefix length. So by over here, and you also need to indicate first usable host address. Look at the title first, the header over here, and tell you what you need to write. Okay, don't simply throw the value in, because there is a student, they are your senior student, they did not think about the title. He used to refer to the workbook, the format of the workbook or the tutorial question. He just dump in the value. Once the value you dump in, but it's not refer to the right title, then you have a problem. Just like maybe the broadcast address he replaced over here. He don't have a first usable host address. Possible one, okay? That is possible to do so. So therefore, I'm going back to over here. So how can I go and look for the address? So now, what is a magic number over here? Okay, what is a magic number over here? Okay, so now looking at this side, okay, over here, so we will going to have a first these 2. Okay, so I'm going to expand that side. So over here, 1, 2, 3, 4, 5, 6. Okay, 0, 0, 0, 0, 0, 0. Okay, 0, 0, 0, 0. I use the bit pattern first. So the first bit pattern definitely this is a bit. The network portion bit. So the in front the number will not be changed. That's why I will going to write 17. Is it called 17? 128.77. So 12 correct. 12 no. So I use 128.77. This 2 bit cannot. So now definitely the first bit pattern from this, the first bit pattern that I can have. Okay, what this mean? I will have a 0. Am I right? Here 0, here also 0. Okay, so you can see all bit pattern is 0. Then from here I can have a bit pattern of 0, 0. And then here I will have 0, 1. Am I right? So over here, okay, I will have a 1, 0. Okay, and then over here I will have 1, 1. Do you see that? I just show you the bit pattern. What is a value magic? This is a 1, this is a 2. And here will be a 4. Okay? So I'm talking about possession value. So the bit pattern, the first bit pattern that you have in your network portion is 0, 0, 0, 0, 0, 0, 0 lah. So decimal value all 0. Okay? So that's why over here I will have a 0. Okay? Dot 0. So my magic number will be the this 3 here, number 4 here. Okay, am I right? So what does mean a 4 here? So I will, okay, or you're going to see that, and Michelle still understand what is a magic number. Now I'm going to tell you over this side. Just now I mentioned about 2 power by 10, you will have 1, 0. 2 power by 10 is 1024. Okay, 1024. So you're using 1024 divided by 256. Okay, so you divided by 256. You were going to say that why divided by 256? Because one bit pattern here, 1 byte bit pattern maximum is 256. Just now already mentioned. So I divided to have a 256. I wanted to see the magic number. So therefore, I'm using divided, okay, divided by 256 equivalent to 4. So this is a magic number. And this 4 will going to tell me how I should going to change my bit pattern. So that's why over here I will have 128 pi 77 pi 4.0. Because remember, I told you network portion all becomes 0, 1. Okay, and this, okay, this one is telling you under my address. This is the address talking about, this is the address that we're talking about our host, how the hosts are going to change. Okay, until you have a first host, then you change. Total up here, you have 1024 addresses. So I divided here. I wanted to find out my magic number. Remember the line, the line I draw here, and the line before your host portion. This bit is a magic number, and I will have 128 plus 77.8.0. Because remember, under network address, all the host portion bit are set to 0. Then I get this magic number is because I can directly plus it. And just now I using 110, okay? 1024 divided by 256. My magic number is 4. I just wanted to confirm to you that this 4 and this 4 are the same to tell you the magic number. And you were going to say that, Mitchell, I'm still not getting you. Okay, don't worry. Let me finish this and I give you a more detail. 128 plus 77. 8 plus 4 will be 12.0. So this is a network address. And the prefix length all are the same because in front you have a 16-bit. Now 16 bits for network portion, and now you have added another 6-bit for the whole from the network portion. Okay, mean that 16 plus 6 will be 22. Here will be a 22. Okay, so now here will be a 22. Here will be a 22. Here will be a 22 because 22. You already have a 16-bit for your network portion, and now you borrow 6-bit from the host portion to become a network portion that will be another 6-bit. So you plus it together will be 22. Okay, that is the thing. And now I'm going to tell you why I'm say magic number. You see that, Amisha, I cannot get you why you divided. Okay, remember the previous concept that I given to you over here. If you recall this. Okay, I say this is a 1 byte, 8-bit. Okay, the bit pattern that you change, you modify your bit pattern, your combinations of your bit pattern, you will have from .0 to .255. And .255 is a maximum. It's a maximum of the value, maximum of decimal value in your one octet. One octet, that is a maximum. Okay, so from 0 to 255 total up, you have 256 numbers. Total up, you have 256 number there. 0 count. 0 is one number, 255 until 255 is another number. So total up between 0.0 to 255, you have 256 address. So therefore, over here, you are saying that in this case, you saying that you have 10 bit. You have a 10 bit for the network. You have a 10 bit for your host portion, and total up you have 1024 address. But the maximum address that you can have in one octet is 256. Therefore, I'm going to divide it. That's why I'm going to divide it. I'm saying that, okay, now I'm using 254. I divided because this is the maximum number I can use to represent in one binary, 1 byte in one octet. So I will going to say that how many set over here is referred to how many set of 256 that I need to generate this 1024. Again, the magic number 4 here actually is referred to how many set of 256. Then I will able to generate this 1024, which is equivalent to your 2 power by 10. Not divided by 255, because I'm talking about your bit pattern changes. So therefore, they're telling you that you need to have a 4 set. You need to have a 4 set of 256. Then you will get this number of 1024. And what is the 4 set here? So under your bit pattern here, you can see me Chaw using .0. Okay, .0. .0 is considered one set. One set. .1 consider another one set. Second set. .2 is another one set. Okay. Dot 4 is another one set. So total up, I got 4 set. But my value is, sorry, not dot 4, it's dot 3. Yeah? Can see or not? Dot 3. So total up, you will see that at mid-child, why they were going to look at this magic number when you are close to a second octet, close to the another octet, then you need to be careful. Okay, because your number of host addresses are very large. You cannot say that, oh, mid-child like that lah. We write 128.77.1024. No, we cannot have this kind of addresses because 1024 is a total host address that you have. It's not the format of IP address. We cannot write 1024 because maximum value that you have is 255. Maximum value you can write is 255. Cannot be 1024. So therefore, I'm using this magic number to find out the combinations of the bit pattern that I need to have. So in this case, what I need to do here is, I will have this value, okay, 128, no change, 77. So because it's a first usable address, so the magic number, this you need to pay attention in terms of this octet, because this is a combination of network address and also the host portion. So that's why you need to pay attention from this octet. Okay, so that's why I'm still starting from 0. And just now already telling you, we are modify our host addresses start from the behind. So now you're talking about your first usable address. That's why I should modify until the behind. This is the first set. Under the first set, dot my first 0, the bit pattern 0, 0, 0, 0, okay, 0, 0, 0, 1, okay. This is a usable host address. So now, what is a broadcast address? My broadcast address is before the last. I do a broadcast address first. 128.77.3. And the magic number here, I cannot largest by 4 because 4 is belong to the new subnet already. Belong to the new subnet. So what is the last set? The last set is set number 4. Set number 4 means that the value is dot 3. Okay, you can see the combination here. 1. Am I right? The dot 3. Over here, I'm looking at the bit pattern here. This is the dot 3. Dot 3. 1 plus 2 dot 3. Okay, so this is a maximum bit pattern that I can have. So that's why over here is dot 3. Then broadcast address, because the entire here is for network portion. That's why, for host portion. That's why all bits set to the 1 is a broadcast address. This is a 255. So over here, the last address is 128 plus 77 plus this 3 plus this 254. So actually, I look for the magic number is for you to easily do calculation. You just need to plus only because the size of each of the subnet here are the same. Or you have a same usable host address. So that's why over here, I will going to write 128 plus 77.4.1. Okay, my broadcast address will be before 8. You're going to minus your 8 by 1. So this one is 77.7.255. And this is 128 plus 77.7.254. Okay, so is there any question you wanted to ask before I end the class? Is your tutor telling you the magic number? Okay, usually magic number not only apply to here also the same thing. Once you're able to find the magic number, you just plus your magic number. Okay, use your magic number and do plus. Okay, so 12 plus 4, 16. So that's why I know this is a 128 plus 77 plus 16 plus 255. This one is 128 plus 77 plus 11.255. Okay, so same things. This one you can do. Remember in the exam, you don't go to say, oh, dot one enough already. Cannot. You must be go and give a complete IP address. Cannot just dot only or dot one, dot 3, dot 254. Even though the in France numbers 128.77 are the same number, you are required to redundant to write it as a complete format of IP address. So don't just give a complete IP address. Else they were going to consider wrong answers one. Must be hit. After you done it, you do a calculation one more time. Don't think that sometimes you copy, sometimes I copy, I rewrite the numbers. Sometimes you will make a mistake. Okay, the number write wrongly. It's happening to a senior before. Okay, so is there any question before I'm stop? So we still have a question, and this calculation is enough to do your subnetting for your classful subnetting in part B. Okay, even though your part B assignment question may use a class C address. Okay, but also you will find out the magic number and you just plus only. Okay, so this is how to do it. But the magic number is only apply for classful subnettings. You cannot apply it into VLSM, or we call it as a classless subnetting. Cannot, because the size of each subnet in classless subnettings are different. Okay, for classful subnetting, each of the subnet, the length, the maximum number of usable hosts in your each subnet are the same. Okay, they are the same. So therefore, you can use a magic number and directly plus the value. Then you will able to know your second next or the next subnet address. Okay, so I'm stop here. If you have class, you can go already. Okay, so let me answer your friend. If you have class, you can go already. So Wong recording Karen, why is not 2 power by 6? 2 power by 6 is talking about you look for number of networks you can be created. That is 2 power by 6. So just now over here, because you are borrowing, just now I didn't mention over here, you borrow 6 bit, from the host portion to become network portion. Original, because 128 is belong to class. Okay, 128 is belong to a class B. Is belong to the class B. Class B, 128. So original, you already have /16. And due to the question, you wanted to have 16, 60, not 16, 60
Miss,
subnet.
I'm seeing B1.
Huh?
B1.
B1 this one.
Uh,
B1. You talking about this one?
yes.
You're talking about this one? Okay. So this one is because this thing is subnet. This is a subnet mask. It's telling you that how many bits already been used for a network portion and how many bits been used for a host portion. And in front here, all 255, 255, 255, it means that the first three byte here already used for network portion. Definitely in front there is no host portion bit, but come to this value 128. This is a decimal 128. How can I get 128 in binary pattern? What is a binary bit pattern in 128? Okay, so if you use calculator, okay, I make it make sense for you. So if you use a calculator, I'm given a decimal value 128. So the bit pattern is 10000000 over here. So therefore, over here are telling you, just now I already mentioned, this is a subnet mask. You set 1 is referred to network portion. You set to 0 is referred to host portion. So in this case, this particular decimal value change to the binary, the bit pattern is 10000000. Question already, just now calculator already show you. Okay, and from here, telling you that how many 0 over here? 1, 2, 3, 4, 5, 6, 7. You have 7 bit belong to the host portion because 0 set, you set 0 is represent host portion. That's why I'm using 2 powered by 7 is equivalent to 128. I need to find out usable host IP address. That's why I minus 2. I will get 126 usable host address. Okay, so remember this one is in terms of decimal value, decimal value position value. This is a 1, 2, 4, 8, 16, 32, 164, 128. That's all 8. Am I answering your question?
Yes, thank you.
Thank you. So need to show calculator formula in the test or can just direct answer? You show the calculation. You need to show the calculation also. Need to show. Depends on the question. Usually they will the answer definitely is answer there. Okay, you can directly give the answer, but a certain question they will tell you that you need to show the formula, the calculation. Okay, for a practical test, I didn't ask you to show the formula. I directly just ask you to give the addresses. But I'm not sure how the final exam question look like. Okay, but when you're able to find the answer, definitely you will able to get the, you should have the formula there. Okay, so now, sometime you, what I mean, you better to write your calculation formula. Sometimes maybe your answer is wrong, but the formula still have a mark. Your step may have a mark, depend on the marker. Okay, so therefore you should show the calculation, the step. Okay. Wait, so we cannot use VLSM for my puppy? Yes, you cannot use VLSM. If you are using VLSM in your puppy assignment, then you are totally out of the topic. Your assignment will be not according to the requirement. So I'm going to show you your assignment. Okay, questions over here. The questions already clearly mentioned to you. You are required to use classful subnetting. Okay. Okay. So over this side, can see the requirement under the Part C requirement. Design suitable classful subnetting IP addressing scheme. This is the key point. They are not asking you using a VLSM. Okay, so who are using VLSM, you need to change on it, else you are not fulfill the requirement. Okay, and the tables that you are the addressing table that you created, you are not fulfill the requirement. Okay, so any other questions that you need to ask? Cannot simply you must understand the question requirement. Um, Part B is in the question had already mentioned using classroom. I think yes. I think I saw the opposite. Okay. Project. Yes. It should be include our introduction. What should we include in our introduction? Just introduce your subnet. Okay. Just now you learned about your subnettings already. Am I right? So over here, even though here given you an introduction, actually more on table of contents, just now introduction. So you're telling us that your part B, you can say that okay, doing this networking, we learned about via SM subnet and so on. Then your part B, you're doing what kinds of network and the concept. Okay, so you at least you tell me what you have been learned little bit. Okay, what you learn from this course. Okay, in terms of networking. Okay, the concept something. Then talk about uh, the document from your part and part B. Not necessarily should be a very long paragraph. Just a very simple a short paragraph that just introduce about networking, what you have been learned. Okay, in terms when you saw the networking, this word, what you have in, what are the concept or minds concept that you have in your mind. Okay, at least I wanted to know whether you get the right thing. Okay. Whether you get the right thing about networking this term or not. So sometimes a student think that networking what is a networking or join the PC together maybe this is what you understand, and then we need to have an IP addresses okay, we link together, then we talk about each other. So it's a very free hands, you can write anything that you understand about a networking. Okay, so next thing, mean that if we use classful subnetting, we cannot use octet number to differentiate different location. We still have a number. Okay, we still have a can differentiate the location by department also can. Okay, Ming Nielsen over here still can, because just now you were able to see here. Okay, you can able to see just now. Let's say, okay, just now we created this subnet okay, we created this subnet so we created this subnet example. Okay, created this subnet. Okay, maybe I think that okay, we have this subnet. Okay, so this address we use for location, A example. This subnet we use for location B. You possible. Okay, but you think carefully. Okay, it means that you have this subnet, you created this address range already okay, okay, here. Okay, let's say this is a class, this one is class B okay, this is a class B, and you think that okay, I have 64 based on the assignment part B. I think my subnet I want to have a 64. Okay, I think I will have a future, my company will be expand a very big subnet. So that's why I'm design using class B. Okay, class B. I'm chosen to use the 127 dot something 16.0.0 from this to do subnet. So then you say that okay, this is a location A. Okay, location A by right only 10 PC, but now you given 1022 addresses. Okay, let's say 1022 hosts, mean that actually you are wasted a lot. You wasted a lot of addresses inside your location A, because under the location A, we only say that we have a 10 PC. At that moment, you have a 10 PC. And I didn't make the Part B question complicated to indicate the future expansions, the percentage of future expansion. Or sometimes the question, if you look at the workbook, under the last few pages, they will have a question saying that you need to consider the organization will be expand, the network will be expand, how many percentage, and so on and so forth. So I didn't do it so complicated. So you still make it as, oh, this is a location, this is a location B. Okay, so this is an address that usable host addresses that you can use. So you can decide that, okay, I want to reserve certain number of addresses for intermediate devices, okay, or start from this address is used for end devices. You can do so. So we did not set how you assign the address to your devices. Whether first usable address or second usable address, we don't mention this. We are not like a packet tracer exercise, which you have done it in your part A. The two question there, they tell you must be first usable used for the router, first usable used for the router interface. We don't have that because that one is mainly wants to configure, to have an auto marking feature to ensure you configure the right IP address according to the instruction given. Okay, but for your part C, part B, you are the one who design the network. You are not auto calculate and do configuration. Okay, what is the digital resources? Under the digital resources over here, if you're going to see that under this side, I already given to you the digital resources. Okay, so for these assignments here, because our assignments are doing a packet tracer we're using, and we cannot give you all the hardware equipments, all the PC, give you a 20 PC, 40 PC, and do a connection. So we are using a digital resources to create, to learn the concept of networking. So that's why under the learning outcome over here is use the digital resources to complete the task related to the network configurations based on given resources. So therefore, I must be know what kind of digital resources that you have been used when you're doing your assignment. And I already give you the hints over here. Okay, under the instruction here, I give you the hints over here. You may use different digital resources. Maybe you have installed the Thim viewer to let your partner to remove access to your PC and he do a configuration, then you go and do something else. So you are doing a teamwork together using Thim viewer. Or definitely you sure you're going to use a Cisco packet tracer. And you may come to the NetAcad, the online NetAcad material there, and to look for it. So you just explain you have used TeamViewer, maybe you have using a Google Meet, okay, to do a discussion with your teammate and so on. And you also need to do a recording. You need to record your video. That's why you need to indicate, you need to mention what kind of software, the recorded video recording software that you have been used to do this video, to compose this particular video. Or maybe you are referred to the YouTube and learn how to do a configuration, how to configure the wireless and so on, wireless router. All this is a digital resources. Therefore, under here, you are required to explain your digital resources that you have been used in your assignment. Okay, so I hope I explain the concept for you, digital resources. Classful mean that cannot borrow bit, right? No, classful can borrow bit. Classful is borrow bit. Classless is keep how many bit. Classless is think about keep how many bit. Classful is borrow bit from host portion to become network portion. Okay. Anything else? Now it's 10:20 already. If no problem, then I'm stop here. I'm stop here. Okay, so no problem. Then I stop here already. I hope I clear your doubt. Okay, so that's all for today. Thank you to everyone.
Thank you, Miss.
Then bye.